Interstellar travel has always fascinated humans, but we lack the technology to travel efficiently to even our nearest planets. It would take us 8 to 9 months to travel to Mars and 73,000 years to travel to our nearest star. But is there a way that we can travel at near to light speeds across the universe? There is. Antimatter propulsion. But why do we need new rockets? It all comes down to speed and specific impulse. Specific impulse is how much thrust you can get out of a certain amount of fuel. So if an engine has a higher specific impulse, it means that it can produce more thrust with a lesser amount of fuel. Now our current chemical rockets have a very low specific impulse. So we have to carry tons of fuel to produce a very little thrust. So it's obvious that we need a much better way to explore the universe. Even though many new ideas have been proposed, the one that stood out is antimatter propulsion. But what is antimatter? Antimatter is matter that exists in negative state. It is opposite to normal matter. Antimatter consists of subatomic particles that are opposite in charge to normal subatomic particles. Antimatter consists of subatomic particles like the antiproton, positron, and antineutrons. Antiproton has a negative charge, the positrons have a positive charge, and the antineutron differ from the normal neutron in composition. But what happens when matter and antimatter meet? Just like when we add a negative and a positive number, they annihilate each other, but in this case, leaving behind pure energy. But what makes antimatter so special is that their whole mass is converted into energy. Even nuclear reactions that power atomic bombs convert only 3% of their mass into energy. Now that we know what antimatter is, let's understand antimatter propulsion. A more efficient way of using the annihilation energy is to use it directly. When an electron and positron annihilates, they leave behind gamma rays. Since positron annihilations leave behind gamma rays with a low energy, we should be able to use a parabolic reflector that can collect and project this energy as thrust. This is known as positron beam propulsion. If we are able to make antimatter in sufficient quantities, the next problem we'll face is storing them. Since antimatter reacts with normal matter, we can't just stuff them into a flask, but instead they have to be stored in magnetic and electrical fields. Antimatter spacecrafts can take space exploration to the next level and expand our understanding of the universe. It can take us to extraordinary distances and places we have only dreamed of exploring. It is only a matter of time.